StarCraft Brood War is a real-time strategy game developed by Blizzard Entertainment, and has been used as an avenue for AI research for over a decade now, with some of the earliest StarCraft AI competitions dating back to as early as 2011, many of which run annually to this day. In a typical 1v1 match of StarCraft, each player chooses one of three races: Protoss, Terran, or Zerg, each with unique units and strategies. Players start with a main base and a few workers, with the core gameplay loop revolving around gathering resources to build structures, unlock advanced technologies, and grow armies to destroy the opponent's units. At the same time, though, the opposing player is trying to achieve the same goal. Players must scout their opponent for information, adapt their strategy, and manage their units in real time to maximize their chances to win. What makes StarCraft especially challenging for AI is the complexity of these tasks. Decisions must be made quickly, information is incomplete due to the fog of war, and the manipulation of units in real time is a challenge for AI to address. The goal of our agent, ProtoBot, is to participate in these AI tournaments and to address the problems that StarCraft raises in our own student project, hoping to maintain a respectable win rate in the StarCraft AI community and to experience the challenges of rule-based approaches in game-playing agents. Now that you have a little bit of background on the core gameplay loop of StarCraft, before describing the software architecture of ProtoBot, we must first address how we're able to play StarCraft. To play StarCraft matches using code, ProtoBot uses the Brood War API, otherwise known as BWAPI. BWAPI is an API that sends 11 unique StarCraft events to allow for processing of possible actions. BWAPI also provides data on the state of a StarCraft game, not requiring the movement of a screen to be necessary in order to see information. This allows ProtoBot to control units, construct buildings, and execute intelligent actions based on the information learned over the course of a game, and information currently present, all with C++. ProtoBot consists of 6 rule-based modules that are designed to address the tasks a human player would have to normally execute in a StarCraft game. The combination of these 6 modules and multiple subsystems is what results in ProtoBot being able to execute intelligent actions and win games. Let me now break down each of ProtoBot's main modules and what each module is responsible for in detail. The Economy Manager is responsible for the farming of resources StarCraft makes available for players to grow stronger. StarCraft consists of 2 types of resources a player needs to create units: minerals and gas. The Economy Manager consists of a mineral locking algorithm that assigns units to a resource until they are either destroyed, a resource is depleted, or a worker is transferred to another base. A benchmark was run and resulted in data that achieves farming that is comparable to the mineral farming of Lettabot, a StarCraft AI created by UC Berkeley. The Build Manager is responsible for the placement of buildings across the map. An open source library that the StarCraft AI community has created, called the BWEM and BWEB, break down maps into data that ProtoBot uses to find placements the algorithm generated, and for the collection of StarCraft map data to be more manageable, allowing for the placement of buildings to resemble human placement and for computation time to not be spent optimizing these placements. The Scouting Manager is responsible for maneuvering units with the goal to get more information during the course of a game. Due to the fog of war, humans have to perform actions to scout out information about the enemy and what kinds of strategies the opponent is going to attempt. When ProtoBot requests for more information, the current combat units ProtoBot has will be assigned to Scout and gain more information, all while trying to be as annoying as possible to the opponent bot. The Information Manager is the way we're able to retain anything new we learn about the opponent. In a normal StarCraft game, a mechanic called the Fog of War prevents players from seeing information about each other. In order for ProtoBot to remember any information we obtain, many different data structures have been put in place to make sure we remember any information we learn until it is no longer necessary, allowing ProtoBot to adjust actions based on what we currently see and have stored. The Strategy Manager is how information is used to command new actions. Being solely responsible for the macro and resource management, the Strategy Manager makes the big decisions about what actions will happen at a high level, to allow other modules like the Scouting and Combat Managers to operate. The Combat Manager, on the other hand, looks at the game at a smaller scale, breaking down groups of combat units into squads. Each squad consists of 1 leader and up to 11 squad mates, allowing for the manipulation of units to be more feasible than looking at every combat unit ProtoBot currently has. This allows squads to maintain their own internal state to react to the game based on the actions received from strategy. There are 4 states a squad can enter, with each state mimicking the overall manipulation of units similar to humans, allowing ProtoBot to attack, defend, and reinforce other squads. To test our agent, we submitted ProtoBot to Basil, an online league where over 100 StarCraft Brood War bots compete 24/7. Some of these bots have even been around for over 15 years. After 400 matches, ProtoBot version 1.0 achieved about a 19% win rate. While that might seem low, it's actually a very solid starting point given the difficulty and cumulative knowledge of other agents. We also received useful feedback from top bot developers, which has been helpful for improvements for our final version. Working on this project really showed us how challenging it is to build an intelligent AI. Rule-based systems can only get you so far because they struggle to handle the game's complexity. On the other hand, machine learning requires large amounts of data and resources, which can be difficult to manage. Even with these challenges, we were able to achieve meaningful results with this senior design timeline, and overall, this project has been a valuable experience in designing complex systems and applying real-world AI concepts. Game-playing agents also go beyond just StarCraft Brood War, with games like StarCraft 2, Dota 2, League of Legends, and more being used for AI research, allowing for potential agents besides just StarCraft Brood War bots to be made by students. ProtoBot can serve as a foundation for these students, showing both how to structure an agent and what challenges to expect.